On March 24, 2026, OpenAI permanently pulled the plug on its Sora video generator. Disney immediately terminated its entire partnership, with the company canceling a proposed $1 billion investment and yanking the licenses for over 200 properties. Throughout 2024 and 2025, into massive opaque neural networks, human-level intelligence would naturally emerge. That strategy hit a physical limit, known as the 100-gigawatt wall. Generating highly realistic, cinematic video requires immense inference compute. Inference is the actual processing power a model consumes every single time a user asks it a question or prompts a video. For Sora, these power costs were so high that OpenAI could not scale the product profitably for public use. The commercial viability of these massive video models collapsed under legal pressure, too. The platform flooded with deepfakes of deceased celebrities, triggering severe moral backlash and a wave of copyright lawsuits. IP holders ran for the exits, deciding the legal liabilities outweighed the entertainment value. To survive, AI companies are pivoting to agentic AI, autonomous systems designed to plan, use digital tools, and execute complex software tasks without constant human oversight. The sudden death of Sora is a brutal economic correction. The tech world is abandoning expensive, energy-hungry video generation to focus on rebuilding the internet's core infrastructure. Asking a single massive language model to build a complex software program leads to failure. These models suffer from context anxiety, a failure state where the AI's memory window fills up, causing it to rush the job and leave a mess of broken code. They also have a self-evaluation blind spot, consistently rating their code as functional even when it is completely unusable. To fix this, Anthropic replaced the single model approach with a 3-agent system inspired by GANs. A GAN, or Generative Adversarial Network, is a machine learning framework where different models compete against each other to force better results. Anthropic's new architecture splits the workload between a strict planner, a generator that writes the code, and an aggressive evaluator that constantly tests the output for bugs. To cure context anxiety, Anthropic engineered a mechanism called context reset. Every time the generator finishes a single module of code, the system wipes its short-term memory. The next generator instance boots up with a blank slate, armed only with the exact specifications it needs for the very next step. In a recent live test, this strict adversarial loop ran entirely unattended for 4 hours. It spent exactly $124 in compute tokens. By the time it finished, it had successfully built a complete, fully functional digital audio workstation from scratch. Human engineers are no longer using AI as an assistant. They are deploying autonomous digital factories that manage, critique, and correct their own work. Millions of these autonomous agents, constantly reasoning and checking each other's work, creates a massive data bottleneck. The traditional data center is powered by x86 chips. x86 is the microprocessor architecture that has prioritized complex, multi-threaded tasks for decades, making it poorly equipped for the relentless, independent microtasks generated by AI agents. That hardware mismatch forced Arm to break its 30-year business model. Arm is now manufacturing its own proprietary AGI CPU, designed specifically to destroy this memory bottleneck. They achieved this by using a single-core, single-thread design. By dedicating one core exclusively to one independent agent thread, the chip guarantees low latency and prevents the processor from slowing down under heavy loads. The physical density of this design is significant. A single liquid-cooled server rack can hold 45,000 of these cores. For the companies building giant data centers, this density cuts power consumption and saves up to $10 billion in CapEx, the upfront infrastructure spending, for every gigawatt of power deployed. The hardware landscape is shifting. To feed the concurrency of agentic AI, the industry is moving towards specialized, hyperdense silicon. Putting autonomous agents in charge of executing code across the internet creates an immediate vulnerability. When AI systems act independently, every open-source library becomes a potential entry point for attackers. On March 24th, an open-source Python library called LiteLLM, which handles 97 million downloads a month, was silently compromised. Hackers breached a security tool and stole its CI/CD tokens. These tokens authorize automatic code updates, allowing attackers to bypass human review. The hackers planted a malicious .pth file inside the update. A .pth file is a Python configuration script that runs automatically when the software environment boots up. Developers never wrote a line of code importing the infected library. The moment their server turned on, the malware executed instantly. Inside, it hunted for sensitive assets, silently extracting secure shell keys, cloud credentials, and cryptocurrency wallets, beaming them back to the attackers. Security tools missed the breach. The attack was exposed because the hackers wrote sloppy code. Their malware accidentally triggered a fork bomb, a bug that rapidly duplicates a process until it eats all system memory, crashing an AI coding tool and alerting researchers. This incident shows that a single compromised open-source dependency can now weaponize millions of connected machines, proving that even a single hidden file can bypass modern security protocols. The fragility of this new autonomous infrastructure has forced global governments to rewrite their regulatory frameworks. Superpowers are now in a race to control the silicon and the energy required to run these systems. European leaders gathered at the Paris AI Action Summit to mount a defense, announcing a massive state-funded initiative to build a regulated CERN for AI. By building their own massive computing clusters, much like CERN, Europe hopes to reclaim control over its digital infrastructure. The United States responded with the 5C policy framework. This is an aggressive deregulatory push designed to remove state-level hurdles. It protects AI companies by classifying training data under fair use, completely removing legal barriers to data collection. The American strategy prioritizes rapid development. They are accepting the risks of unregulated innovation as a requirement for maintaining global technical dominance over foreign rivals. We have entered a high-stakes engineering war. Global supremacy now belongs to whoever controls the silicon, secures the code, and deploys the best autonomous agents.